In this video, we're going to look at some descriptive measures, including these things here: range, median, mode, and mean. Weighted mean, percentiles. We're going to look at some standard deviation. The first thing, I'm going to give you a data set here, test scores. Now this could be any kind of data set, but we're going to look at test scores. And I've got 8 here, and I'm going to find these things for these 8 scores. In the red here, what I've gone ahead and done is ordered them from least to greatest. That will help us to find the range and to find the median. So it's just helpful in general if you have a data set to order them from least to greatest. The range is just the highest value minus the lowest value. So in this case, that would be 99 minus 45, which is 54. So that just shows the range of data. It's kind of what it sounds like, the range of the data. The median is the number directly in the middle. The easiest way to do this, especially with a smaller data set, there's a way to do it with a lot, but we're not going to explore that right now. Just cross one off from each side until you get to the middle. If there's an even number in the data set, you'll end up with 2 in the middle, like this one. So if that happens, you just take the average, which is 88 plus 84 divided by 2. So you just take the sum of the data items divided by the number of data items. And that's going to be 172 divided by 2, which is 86. So your median is 86. Now note median, that is not actually one of your data items, but that's okay because it still falls right in the middle of the data. And if there were an odd number, it would just be the one that you were left with when you crossed off from each end. The mode is the number that occurs the most. So if there's one that occurs the most, that is your mode. In this case, it is 88. It is possible to have more than one mode. If you had 2 of one number and 2 of another one, and then everything else was just one of that number, then you would have those both be your mode, and that's fine. Mean, I'm not going to spend a lot of time on this. I mentioned it here. You just take the sum of all the data items and then divide by the number of data items. If we add all of these up, we would get 638. And there are 8 of them, so we divide by 8. And that would give us 79.75 as our mean. So those are kind of some good things to use to help us here. Now, there are something called outliers in a data set. An outlier is kind of what it sounds like. It's something that falls outside of the general range of data. So like if I were looking at this data set and then I had a 0, 0 would be an outlier. That means most of my scores were between 45 and 99, and I just had that one that was way off. So that would be an outlier. That will, if you have an outlier, it will affect your median and your mean, but it will affect your mean more than your median. So a lot of times we use mean or average to describe a set, like, okay, the average of a set of data is this, and that's what we use to describe it. But sometimes, if there is an outlier, the median can actually help us kind of nail down more specifically what that data set is telling us. So, because if you had the median, you'd still be crossing out from each side, and we would have ended, if there was a 0 here, we'd end up with 84, which is still pretty close to what we started with. But if you throw a 0 into your mean, that's going to pull that average way down. And so if you just had the mean from a set of data, it would look like, man, the test scores were really, really bad. But they actually weren't that bad. There was just this 1 0. Of course, there are a couple bad ones there, but that 1 0 really pulled that average down. So if you have the mean and the median, it helps determine, it gives more information about the set. All right, so weighted mean and GPA, I just wanted to show you one of these. You do have a couple of examples in your problem set, but I like how this relates to your GPA. So a weighted mean, if all of your courses are the same number of credits and you get the same GPA, if they're all the same credits, then you can just take your GPA, add it up for each course, and divide by the number of courses that you have. But if you have a different number of credits, then they're going to be weighted scores. So even though you have a 4.0 in this class, it's not weighted as heavily as these classes that have 3 credits and 4 credits. So what we do is we take the scores per credit hour and divide by the total number of credits. So basically, we're just going to go through here and multiply these out. So if you have a score of 3 GPA at 3 credits, that means you have 9 total if you multiply them. So you have the 3 credits. So for each credit, you get that score of 3.0. For each credit here, you get that score of 3.5, which is going to be 14.0. And here, for this one credit, you of course just multiply that, it's good 4.0. So again, for each credit, you get this score. So if you only have a class that's scored, or that's one credit, you only get that score once when you're considering that weighted mean. So what we're going to do is get that weighted mean. We're going to take these and add them up. So 9 plus 14, it's going to be 23, plus 4 is 27. So we're going to take that total 27 and then divide it by the total number of credits. So not classes, but credits. So 3 plus 4 is 7, plus 1 is 8. And then that, when you divide 27 by 8, you get 3.375. And that would be your weighted average. So you might be looking at this and thinking, well, I got a 3 and a 3.5 and a 4. Shouldn't it be 3.5? Because that's right in the middle of all that. Well, if they were all weighted the same, then yes. But because they're weighted differently, we had to calculate it this way. And actually, it's a little bit lower than that because that 4.0 didn't have as high of a weight there. Okay, so moving on to percentiles. Percentile, you had seen this like if you've been to the doctor's office with your kid or a niece, or when you were little. You might hear like, you know, oh, your kid's in the 98th percentile for weight. That just means that they are heavier than 90% of the kids that fall in the same category as them, so whether that's age or whatever. So what we do to find the percentile, I've got some steps here, and I'm going to show you an example in a minute, but we've got, what you're going to do is you're going to take n, which is the total number of operations. So if you're finding the pth percentile of a sample of n, you take the number in the sample times the percentile that you're trying to find out of 100. Then we're going to order the items from least to greatest. And when we find this n times p over 100, if it's not an integer, we're just going to round that up. And then we're going to take that position in the order. So if we get a 3, we're going to find the third one in the order from least to greatest, and that is going to be that percentile. If it's not an integer, or sorry, if it is an integer, if you're doing this and you get an integer, then we're going to find that position and the next one and take the average of the two to get that percentile. So I'm going to show you an example of this because I know that's kind of a lot of information in one step, but I think when you see this applied, it'll make sense. Okay, so we're going to take, I'm just going to give you a random list of data. And actually, I'm going to look at it as this is weight of babies. And I didn't get more specific than that here, but I'm going to just list out, I'm going to go ahead and put them in order from least to greatest just to save some time because I'm sure that y'all are able to do that. Okay, so I've got these in order from least to greatest. Now what I'm going to do is I want to find the 25th percentile. Okay, so what I'm going to do is I'm going to take the number of items is n. So n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n equals 10 items, 10 weights in this case. So we're going to take n times p over 100 is going to be 10 times. P is the percentile that we're trying to find, so 25 out of 100. And then just multiply that. This is actually 1/4 times 10. If you multiply that out, you're going to get 2.5. So 2.5 is the value we get from that. Now if we look down here, this says if n times p over 100 is not an integer, this is not an integer, it's a decimal value, we're going to take this and round up to the next highest integer, which will be 3. And that means that we are looking for the item in this list that's in the third position. 1, 2, 3. That is in the third position. So that means that 14 is in the 25th percentile. I don't know if that's actually how to write that, but so 14 is your answer to that question. Now, if you got an integer, like let's say that we were trying to find a different percentile and you got 4, then you would find the 4th percentile fourth position, fourth position and fifth position, the next one, and then take the average of those two, and that would be the number that falls in that percentile. So that's what those rules down there mean. So this would mean that in this case, if you had a baby that weighed 14 pounds, they would be in the 25th percentile, based on the data that we have here. Now, generally, if you actually go to the doctor and they tell you something like this is based on a lot more numbers than just 10. But for this data set, that's what that would be, and this gives you an idea of how that's calculated. Okay, so we're going to move on to, this next item is the 5-number summary, which is what your discussion board post is about. Knocking everything off. 5-number summary is kind of a neat thing here. It's just 5 numbers that you use to kind of nail down kind of give you an idea, I guess, of what that data set looks like in general. So I'm going to give you 10 scores. All right, so I've got 10 scores here. Now what we're going to do is we're going to find the 5-number summary for this. The 5-number summary is the minimum. This is the easy part, minimum and maximum. Minimum, lower quartile, the median, the upper quartile, and the maximum. All right, so what we're going to do, and then we are also, this is kind of separate from that, but we're going to find the interquartile range when we're done with this. So I'll explain that in just a minute, but I'll go ahead and list it here as one of the things that we're going to find. All right, the minimum is what it sounds like. It's the smallest number, so 79. Max, same thing, highest number, what it sounds like. All right, the median, we already know how to find the median, so we're going to go ahead and do that. Cross one off of each end. All right, we ended up right in the middle of 80 and 90. So we're going to take that average, just like we have did before. Take the average of 88 and 90 would be 89. And again, to find the average, you just add them together and divide by 2. All right, so that's our median. Then what we're going to do from there is we're going to, and I'm going to kind of draw a line right here. That's our median. And then what we're going to do is we're going to kind of go down and look to the left of our median, and we're going to find the number in the middle of that. Look to the right of your median, find the number in the middle of that. And those are going to be our lower quartile and our higher quartile. So if you look here, we've got 1, 2, 3, 4, 5 items here. 85 is the one in the middle. So that's our lower quartile, is 85. And then if you look for the upper quartile, look to the right of that median. You've got 1, 2, 3, 4, 5 again, which should be accurate since you're looking at a median. It should be right in the middle. So then that's going to be 95 is your upper quartile. So that's what we do to find the 5-number summary. And then to find the interquartile range, what we're going to do is just take the upper quartile minus the lower quartile. So that would be 95 minus 85. And what that tells us, what that data tells us about this is that the middle 50% of those data scores have this range, which is not very big. So like if the middle 50% had a really big range, depending on what that data was, that would tell you that, okay, well the middle 50% has that big of a range, then what does that tell you about the total data in general? And then what's the relationship between the lower quartile and the minimum? If you had a minimum of 79, a lower quartile of 85, but then your upper quartile was 300, then you'd be like, okay, well that's weird. The lower 25% fell within 6, between 79 and 85, but then we have this huge jump in the next 50% from 85 to 300. So this kind of tells you some information about the data without having to actually see the data listed out. This is especially helpful when you have lots of data. So if you had 1,000 pieces of data, obviously you're not going to want to write these all out. and there are other ways to find that, but this data would give you some, without having to look at all those numbers, this would give you a good picture of what those numbers look like in general without having to dig into all the data. Okay, so now we're going to look at standard deviation, and particularly population standard deviation. So I've got the formula up here for this. I know this looks kind of crazy. I will explain this. I'm going to show you kind of a shortcut or easier way to kind of break this down. Okay, so what this is, this little symbol here is theta, stands for standard deviation. Then we have a sigma, stands for sum, x that stands for each item in the set. So here our x values are going to be 4, 6, 9, 11, 15. Mu means mean, and n is the number of items in the data set. So what we're going to do is we are going to find the population standard deviation of this set. Now in your problem sets, the explanations, they break this formula down, but I'm going to break it down even more and put it into a table. I think this is really helpful to find this standard deviation. What we're going to do is we're going to list the x values. Notice what we need to do to that x is subtract the mean. So we're going to have x minus mu. And then after that, we square that value. So whatever we found from the x minus the mean, we square that. And then we take the sum of all of the, write the wrong variable there. Then we take the sum of all of those. And then after that, what we're going to do, we'll finish the formula after that, but this is kind of the key thing. That numerator is the hard part. Once we get that, then we can divide by n and take the square root and we'll be done. But what we're going to do is we're going to list out all of these values, so 4, 6, 9, 11, 15. Those are our x values, the data items. So those are our x's. Now I'm going to take x minus mu. So 4 minus 6 minus, we need to figure out what that mu is. And mu, again, represents the mean, so we just find the mean, add these all up, and divide by the number of items is 5. So we're going to get 45 divided by 5 is 9. So our mean for this data set is 9. So that's mu. All right, so we're going to subtract 9 from each one of these and see what we get. All right, 4 minus 9 is negative 5, 6 minus 9, negative 3, 9 minus 9 is 0, 11 minus 9 is 2, 15 minus 9 is 6. Okay, so again, we're taking the sum of all of the x minus mu's squared. So we need to find x minus mu, we need to square them, and then we need to take the sum of all of that. So x minus mu squared is just going to be what we just got here. So the negative 5 squared is 25, negative 3 squared, which is 9, 0 squared, which is 0, 2 squared, which is 4, and 6 squared, which is 36. Notice that I put these in parentheses because we're not squaring just the 5 and leaving that negative out there. It's a negative 5 times negative 5 will be a positive 36. And then we add these up, so 25 plus 9 is 34, plus 4 is 38, plus 36 is 74. All right, that is the numerator. 74 is our numerator. So this table kind of sets it up for us where we can find that numerator pretty easily. From there, what we're going to do is we're going to take 74, square root of 74 over n. N is 5 in this case. It's the number of data items, so it's 5. So if you go back up to this formula, I just found this portion right here is what I found right here. So that's 74 divided by 5, and then I'm taking the square root of that. So the square root of 74 divided by 5 is 14.8, and then if you take that square root in your calculator, you'll get 3.85. All right, so that is the standard deviation for this particular problem. So again, your problem sets kind of show it in a lot of detail, but it doesn't use this table. I think this table really helps to break it down. So either way, you might find the explanation there good too, but that's how you find standard deviation. So it looks kind of messy, but when you organize it in the table, it's not terrible. So, and again, the standard deviation kind of shows like how much you would expect a data item to deviate from that mean. If you were given, based on the data that exists, what could you expect about additional data? And you would expect that a certain number would fall within 3.85 from that mean. There's a lot more to that, like with statistics, normal distribution, things. We could get into that, but for now, this is all you need to know. So, okay, hope that's helpful, and that's it for this module.